Hey guys, today we are looking at our notes for 6.3 part 1, which is all about logarithms. So this is kind of getting into our crux of our new stuff for this section, or for this chapter. Again, you can see obviously here that this is part 1 of 2. We'll do this started notes today, and then next week we will continue with part 2, getting into a little bit deeper into logarithms and their graphs and stuff like that. So, hopping in here, we got our 4-box notes. Up here in box 1, just looking at the definition of what a logarithm is. Now, logarithm is the technical name for it, but as we'll continue moving forward, I'm just going to shorten it down to log. It's our abbreviation for when we shorthand it in an equation, and just log is so much easier to say than logarithm, so I'll just say logs from here on out. But what a log basically is kind of the inverse of an exponential. So we dealt with exponentials these first 2 sections of chapter 6, and this is just kind of a rearranged version of that. So this, on the left side, we've got these 2 different forms that we follow. So we can see I've got this like little red double set of arrows in between, with one side being our logarithmic form, which I'm going to put here in blue. This is logarithmic form, or log form. And then over here on the right in green, this is our exponential form. So an exponential, we know, like it's a base to some exponent power being equal to some number. So the way we would just rearrange that would be just to put it as our log base b of y equals some number. So in this case, you can see kind of where those connections are. The base is still my base. That's just written as a kind of a subscript of my log. So log base b, log sub b of y equals x. And kind of the question that we're asked here, now here is how it's read, log base b of y equals x. You're basically going through and saying, all right, well, b to what power would give me y? So that's kind of the question that we're asking. I'm going to switch this back to blue. B to what power gives me y? And that's what we're trying to evaluate. Like eventually, when we get to the problems in box 3, we're actually evaluating these. We might not necessarily know what this thing is over here. We're just going to be given our log base b of y. We're just trying to figure out what my exponent could be to give me that answer. So let's first work on, before we get into some evaluation problems, let's work on converting back and forth between different forms. So for number 1 here, we are starting with log base 2 of 16 equals 4, and we're asked to convert that into exponential form. So this is given in logarithmic form. We're trying to rewrite it into exponential form. And you can kind of look over back and forth between box 1 and box 2. We know that log base b of y equals x. That tells us that 2 is our base of the exponential. Y ends up being what it's equal to. And then x is my exponent. Whoops, I wrote x. It should be a 4. So that's the rearranged version of that. We know that 2 to the y power, 2 to the fourth power is 16. That's just rearranging log base 2 of 16 equals 4. And we can do the same thing the other way around. If 8 to the 2/3 power equals 4, we know that log base 8, my base does not change, log base 8 of 4 gives me 2/3. So in this case, the exponent on my base becomes my solution. My base stays as my base, and then my solution of the exponential becomes what I'm evaluating in a logarithm. So log base 8 of 4 is 2/3, and that's because 8 to the 2/3 power gives me 4. Okay, so looking over here in box 3, getting into some evaluation problems. If we're trying to evaluate these, now this is kind of starting us without having both sides of my equation. I'm trying to figure out what my exponent would have to be on my base to give me this evaluation. So kind of like we were talking about in box 4, or sorry, up in box 1, this is really kind of rearranging this. I'm trying to figure out 4 to what power gives me 64. And that question mark that I'm trying to figure out, that's my solution. That's what log base 4 of 64 is. So you can use your calculator to figure this out. Some of us might be able to just go big brain and know that 4 squared is 16, so we need to be bigger than that. 4 to the third power ends up being 64. So that's why in this case, log base 4 of 64 is positive 3. And that's all I have to do for evaluation. Now, obviously, it'll get more complicated depending on what your base is or what your evaluation is. So for number 4, I'm trying to figure out what log base 5 of 0.2 is. So again, if I rewrite this in exponential form, I just feel like that's easier for most of us to try and comprehend. We're trying to figure out 5 to what exponent gives me 0.2. Now, this one probably going to take a little bit of rearranging because most of us, we could guess and check on our calculator, but it might not be something that's quite obvious to us. But what helps me to see this, I can convert any decimals I want to into fractions or vice versa. If I convert 0.2 into a fraction, it becomes a lot more obvious because I'm trying to figure out 5 to what exponent power is 1/5, which that should help us substantially because 0.2 as a fraction is 1 over 5. And we know that the only way that I can get this from 5 to some exponent power to 1 over 5 is if that question mark, that exponent, is a negative. And in this case, we don't want the value to change at all, so it's going to be a negative 1. So that's how I know, in this case, log base 5 of 0.2 is negative 1. Because 5 to the negative first power gives me 1/5, which 1/5 is 0.2. Last but not least, number 5 here. We've got log base 1/5 of 125. So that's what we're trying to evaluate here. So again, I'm going to rewrite this into exponential form. That's asking us 1/5 to what exponent would give me 125. Now again, kind of going back and forth here, similar to number 4 that we were just looking at. If I'm trying to start with a fraction and end up into a whole number, the only way that that's going to happen is if my exponent here is a negative, because that's going to flip my fraction over, just like our regular exponent rules. So then we're really looking at if this is 5 to some negative exponent power, giving me 125, that question mark, that actual digit, that number, is going to be whatever exponent on 5 gives me 125. So again, you can either use your calculator to guess and check this, but we should come to the conclusion that negative 3 is my exponent. That's what my exponent would have to be on 1/5 in order to get 125. Because the negative would flip that 1/5 over to a 5, that 3 would cube 5, and we get 125. All right, box 4, last but not least, a couple of our special cases. So we have 2 special cases and then also some shortcuts. This is how we'll do some evaluation eventually. We have 2 special kind of logs, and they're special in that we use a particular base. So 2 of the most common, I'm not trying to be punny here, but 2 of the most common bases that we can use for our log are what we call our common log and our natural log. Our common log is log base 10 of x. So base 10, we know our number system is base 10, right? We count up to 10 and then we switch to the next decimal place or the next placeholder. So it's base 10. So same thing here, log base 10. Because this is something we use quite often, if we write just log of x, if we don't see what that base is, we get to assume that it is base 10. It is our common log. And there is a keyboard shortcut for that. If you're on your calculator, the log button that just says log of then a number, that's doing the common log for you. Our other one is our natural log. Now in 6.2, last section when we did that continuous growth, we had that equation PERT, right? P times e to the RT power. That e, that number e is our natural number. It's called the natural number. That is what we're going to be dealing with here for our natural log. Our base is going to be base e. So the natural log is log base e of x. And we do have a way of writing that shorthand. Instead of having to write out log base e of x, our natural log is just ln of x, which I usually write it with a cursive letter just because my L's look like 1s, or, it's easy to confuse the two of them. But on most calculators, again, ln of x is how I would write that. So again, on most calculators you have, or almost every calculator has those two shortcut buttons. So if I'm trying to evaluate just the log of 8, we can use our calculator for this. This is asking us log base 10 of 8 is what? But again, our calculator can go straight to that shortcut. If I pull up my calculator here, I probably have to go to, oh no, there they are. So on my calculator, you can see that bottom left corner, I have my log and my ln button. Both of those are my common log and my natural log. Now, we got to play around here a little bit to see how your calculator will do this. Sometimes you have to type in the number first and then hit log. Some calculators, you have to hit the log and then the number. So I'm going to try log and then, yep, okay. So it's giving me an invalid input right away. So on my computer calculator, at least, I have to make sure that I do 8 and then my log first. So if I'm trying to evaluate the log of 8, I end up with 0.903. Now, if you have a regular, like a physical calculator, similar to the ones that I have in my classroom, like a TI-30X2 or a TI-83, on those you can usually type log and then the number. But either way, whatever calculator you're usually using, just go ahead and test that now so that you know whether or not you end up with 0.903, because that's what you should get when you do the log of 8. So 0.903. And then you'll do the same thing for number 7 here, this last one, the natural log ln of 0.3. So on mine, again, I have to type in 0.3 first and then hit my natural log. We end up with negative 1.204 if we're rounding the 3 decimal places. Negative 1.204 is what we end up with. And that's all we got for today. So, homework is down there on the bottom of the sheet, which is on the top of the screen now. It's page 314. You guys are going numbers 6 through 24, just the evens. 6 through 24, just the evens. As always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you soon.